The history of spinal manipulation in all of its many incarnations goes back perhaps thousands of years. Happily for the healthcare consumer, over the last few decades, spinal manipulation therapy has been very thoroughly researched by highly qualified scientists from across the spectrum of the professions. It is safe to say that the consensus is that spinal manipulation therapy, when performed by qualified experts, is an exceptionally useful and safe modality. Students and practitioners can be taught to perform their orthopedic and neurological tests, utilize imaging when necessary, and with time and experience, develop excellent instincts for making the determination of where, when, and how the application of spinal manipulation therapy is indicated. However, professional-level spinal manipulation therapy, especially HVLA techniques, are among the most challenging skills to master. Whether the goal is the reduction of a fixation lesion of a synovial joint or any other problem where the modality is indicated, spinal manipulation therapy requires a very high level of competence and is not without risk, both in training and application. There have been many attempts by scientists from various disciplines to create some type of simulator device to address this problem. The difficulty is that it is impossible to provide simulators for each different body type or treatment scenario. Even if this was possible, it is simply not feasible for each individual student to have adequate lab time and technical assistance necessary for them to develop the required skills. In the early development of the Dynadjust system, it was quickly recognized that the path of the anatomical analog was not a feasible solution. Published research on exactly what comprises the essential elements of safe and effective HVLA procedures have emerged. Many studies, including published research that is specific to the Dynadjust instrument, have clearly demonstrated that training on biofeedback machines does translate into lasting increases in the specific skills required in the treatment of human beings. In approximately 2007, computer gaming systems such as the Wii were introduced. These toys utilize miniaturized gyro and accelerometer technology for measuring motion and force. The advent of these powerful new electronic components was the impetus for further development of the Dynadjust spinal manipulation training system. These components have made it possible for the Dynadjust instrument to accurately measure every aspect of the actual dynamics of the manipulative thrust and to do so safely and effectively in any treatment posture. This virtually eliminates the potential for student-on-student injury in class, as well as injury to the students resulting from old-fashioned training exercises. Another significant advantage to utilizing the new technology is that it is relatively inexpensive. Thanks to the success of the computer toys, these components are readily available and quite versatile in their compatibility with other necessary electronic components. These attributes have made it possible for every student to have access to their own personal Dynadjust training equipment. This allows students to train on their own time, at their own pace, and at any location. With the infusion of substantial capital, intense design and engineering effort, and the support of many professionals in the field and educators, OrthoNeuro was ready to introduce the completed Dynadjust systems in the spring of 2012. The instrument allows the user to closely replicate appropriate treatment postures so that the exercises isolate the specific anatomy of the user for training. The instrument utilizes 4 basic principles of effective exercise: dynamic resistance training, isometric training, plyometric training, and biofeedback training. For the first time in history of spinal manipulation training, we now have an affordable and comprehensive system which combines these proven exercise principles for the rapid development and enhancement of not only the body, but also the central nervous system of the trainee. The Dynadjust system allows the trainee to quickly acquire the ability to modulate the force of their procedures with great precision and control over the depth and direction of the thrust in any treatment posture, even with complex combined motion techniques. It has been reported in the literature that on average the physical skill of field practitioners using HVLA techniques tends to peak at approximately 5 years into practice, and that their ability to modulate the force of HVLA thrusts varies dramatically. The goal of the Dynadjust systems is to close that gap and help standardize skill levels at a much higher level. By providing the opportunity to produce thousands of HVLA thrusts over the course of several semesters with objective analysis and feedback for each thrust, students will develop the physical attributes and skills needed to master the art far sooner and in a much safer and more effective manner. By incorporating the Dynadjust system into the curricula of our colleges, we believe that the physical acumen of our students in force modulation, coordination, accuracy, and control for the full spectrum of HVLA procedures will be radically improved in just 2 to 3 semesters of study. The program is designed to be easily and economically incorporated into any existing palpation or introduction to manipulation course. While this enhancement to the curriculum requires almost no change to the existing program, it will immeasurably enhance the ability of instructors to track the progress of individual students, identify areas of weakness and skill, and provide custom regimens to effectively address and correct any deficit in performance.